In each of these examples, I'm just going to go ahead and just use the substitution method as per normal, and you're just going to kind of see some things happen differently in all these cases, and I'll discuss what's happening as we encounter all of that. So just as per normal, let's just go about solving this by using the substitution method. So we're going to have to isolate a variable first of all. So I'm going to go ahead and try to isolate the x in that first equation. So I'm going to go ahead and divide both sides by 3. That's going to give me that x alone is equal to negative 2y plus 4. So with that, now that I've isolated the x, I'm going to then take the negative 2y plus 4 and then substitute it in for x into the other equation. So that means then I'm going to take 4.5 x plus 9y equals 18, use that equation, but then substitute the negative 2y plus 4 into that. So now we can solve for y in this green equation, do a little bit of distribution. 4.5 times negative 2 is negative 9y, and 4.5 times 4 is 18, plus 9y is equal to 18. We do have like terms on the same side of the equal sign right there. Negative 9y plus 9y is equal to 0. So really we have 18 plus 0, which is 18 on that side, and 18 equals 18. Now at that point, we don't have a y value anymore because we've completely eliminated it, so we actually don't know what y value we have to deal with right here. Now notice that what we do have right here is we do have a true number statement that we've arrived at. So if that happens when you're using the substitution method after you substitute into the other equation, you come up with a true number statement, that's telling you a little bit of something about what's going on with these equations. It does turn out that actually this equation and this equation are actually the same equations as each other. So it does turn out that there will be an infinite number of solutions to the system. So that's saying, again, how many solutions there are. It's not saying what the solutions are. The solutions are going to be all of the ordered pairs on the line, right? So the solutions are all ordered pairs on the graph of the equation because the two equations are the same. And I just kind of want to show you why that is, because if you take this equation right here of 3x and then I'll put plus 6y equals 12, and then I'll take that equation, which is 4.5x plus 9y equals 18. So no matter what, if you do the same thing to both sides of an equation, it's still the same equation in equivalent form. We get 9x plus 18y equals 36. And then with the other one, I'm going to multiply that by 2 on both sides, and you end up getting then 9x plus 18y equals 36. And so you can see, oh, hey, they're actually the same equations as each other. So yes, of course, the solutions will be all ordered pairs on the graph. So you may encounter that when you're solving and come up with a true number statement like that. Okay, so with this one right here, it does turn out that you actually have the y there all isolated. So if we take this right here, 8x minus 11, because it's equal to y, and we substitute it into y in the other equation, then the negative 8x plus y equals negative 13 becomes the following once we substitute. Since it's just plus, the parentheses are really useless. So we just combine the negative 8x plus 8x, you just get 0. So really you have negative 11 equals negative 13. You'll notice then we don't have any variables anymore, but what we actually have right there is we have a false number statement. So what that's actually going to tell you is that there should be no solution to the system when we get a false number statement. And the reason why that is because this first equation, which is y equals 8x minus 11, and then that equation, if I solve it for y, is y equals 8x minus 13. And when you compare them to each other, they have the same slope, but then because they have different y-intercepts, they're parallel to each other, and therefore are never going to cross each other, right, if we were to graph this. So therefore, there is going to be no solution to this. So that's what you'll kind of see when you're using the substitution method, when you run across cases where you have the solutions are all of the ordered pairs on the line, or when there is no solution. So otherwise, when you have like a system like this, and we're going to do some substitution, so let's say that I wanted to get this x alone in the second equation. That means then I would have x equals, by subtracting 9 on both sides, you'd have 3y minus 9. And then I can take this 3y minus 9 because that's what is equivalent to x. Then I can substitute it in for x into the other equation, meaning that then if I take negative 2y plus 5 times x equals negative 45, and then I can substitute that 3y minus 9 in for x into that, then what we're going to see from this is then we will have negative 2y plus 15y minus 45, doing subdistribution, equals negative 45. Then we do have some like terms with these right here. You have the 13y minus 45 equals negative 45. And then we can add 45 and add 45, and you're going to end up with the 13y equals 0. Okay? Now, you still have a y, right? You are going to get an answer with this because you're going to divide by 13, which you can, and you get y equals 0. So there's nothing really special about this because it's just like these examples up here where you are always finding a variable value first. It just turns out that yes, sometimes you can get 0 to be an answer for one of your variables. So it just turns out that, okay, we got the y value here to be 0, and then you can just proceed. So if you just get a number like for a variable, it's just a normal type of problem where you're going to have basically just in terms of the number of solutions, you're just going to have exactly one solution to your system going on. So you can proceed forward from here, and then if you know your y is 0, you could plug that into one of them. So 3 times 0 should equal x plus 9, so 0 should equal x plus 9, and you can subtract 9, so that means that your x value should be negative 9. So this is just a normal sort of thing. Your solution does end up being negative 9, 0 when you check it and see that it satisfies both of the conditions in the system. All right, one last quick little thing right here is just kind of dealing with understanding solutions to systems. So this is a multiple choice question, much like you might see on like an ACT, MCA, or other sort of test you might end up taking. It's asking what is the solution to the following system of equations, right? So if you were to try to solve a system, you could solve it algebraically using substitution. You could also use graphing to do so, but especially in a question where it's multiple choice and right there you've got candidate answers, just use the definition of what a solution to a system is, and that it has to satisfy all of the conditions in the system. So really, you could just plug in the x and the y into each of the conditions. So if I were to take this first condition, so let's say this red condition right here, and check it, I could say that, okay, let's check that 5 times x minus 3 times y is going to equal 4. So I can plug in the 2 and the 2, since those are my x and y. What I end up getting then is I end up getting that 10 minus 6 equals 4, which gives me 4 equals 4. So it works out great there. And then I can also plug into the second one and see if it also works there. So then by doing 7 plus the y equals negative 4 times the x, I can plug in the 2 that is the y and the 2 that is the x, and that's going to then give me that 9 equals negative 8, but that doesn't work. So that tells me then that this cannot be a solution to the system because it does not satisfy both of the constraints within the system. So then I would have to, check B and see if that's going to work. So does 5 times the x minus 3 times the y equal the 4? So we'll substitute in the negative 4 for the x, the positive 9 for the y. So we end up getting from that then negative 20 minus 27 equals 4, which gives us negative 47 equals 4. So clearly that didn't work in the first condition, so it doesn't matter if it works in the second or not, right? We need to satisfy both. So that can rule out B being as a possibility. So then we can check C or check D, whatever you want to check. So let's go ahead and check C. How about 5 times x minus 3 times y is supposed to equal 4. So we'll plug in negative 1 and we'll plug in negative 3. And then we'll do some simplifying. That's going to give us negative 5. Negative times negative is a positive, so plus 9 equals 4. That does give us 4 equals 4. So great, that ended up working out right there. So put a check mark. And then we'll check the other condition, 7 plus y equals negative 4 times x. So we'll plug in the y, which is negative 3, and then plug in the x, which is negative 1. Do some simplifying. That's going to give you positive 4 is 7 plus negative 3, and negative 4 times negative 1 is positive 4. So it worked out there as well. So then, now that you can see, okay, it did satisfy both conditions, then therefore this right here would have to be the answer, because it is the ordered pair among the choices given that satisfied both of the constraints given.